In problem 2, we have to simplify all these radical expressions, assuming all variables are positive. Some of them are as easy as calculating, but others take a little bit more work. For instance, square root of 49, we should just know that as being 7. With the cubed root of negative 64, we've ran into that quite a few times as well, and we should know it to be negative 4. However, if we don't, you can use your calculator to compute the cubed root of negative 64. With example C, when we have the cubed root of 27, x to the 9th, y to the 18th. Finding the cubed root of 27 isn't hard. We've ran into that quite a few times as well, and we should know that the cubed root of 27 is 3. If not, you can calculate it. But what about the x's? Since we're looking at the cubed root of x to the 9th, what I want to know is how many groups of 3 fit into the 9. And that would be 3 of them. So it's going to be x cubed. For the y's, the same thing. How many groups of 3 fit in the 18th power? And that would be 6. So the cubed root of 27, x to the 9th, y to the 18th, is equal to 3, x to the 3rd, y to the 6th. For a little bit more explanation on that, let's go back to that cubed root of x to the 9th. See, x to the 9th can be written as x to the 3rd times x to the 3rd times x to the 3rd. Because when we multiply exponents, we would add their powers. 3 plus 3 plus 3 is 9. Now, finding the cubed root, we would find the cubed root of each of these factors. And the cubed root of x cubed is just x. And the cubed root of this x cubed is just x. And the cubed root of this x cubed is just x. That will simplify to x to the 3rd. See, that's why we wanted all these groups of 3 so that they would cancel with the 3rd root. So let's move on to part D. Before we can start simplifying part D, we need to combine this into one square root. 6 times 24 is 144. And x to the 4th times x to the 10th, we add their powers and get x to the 14th. Now this is a square root, which has an index of 2. Square root of 144 can be calculated to be 12. And when we're looking at the power for x, I want to know how many groups of 2 fit into 14. And that would be 7. In part E, square root of 20. You can try and calculate it, you'll get 4 point something. So we see that it's not going to be a perfect number. So what we want to look for is perfect square factors of 20. And we know that 20 is 4 times 5. So we could take the square root of 4 to be 2, and the square root of 5 is just the square root of 5. When we have fractions, the first thing we should try to do is divide. And if both the numerator and the denominator are under the same root, since both of these are square roots, we take the square root of 28 divided by the square root of 7 and get the square root of 28 divided by 7, which is 4. Now the square root of 4 is just 2. But in part G, we see that we have 5 over the square root of 7. We can't divide those two because that 5 is not under the square root. And 5 and 7 wouldn't really divide anyway. So instead, what we have to do is rationalize the denominator, which means get the root out of the denominator. So since this is a square root of 7, I have to multiply by another square root. And I'm going to multiply both the numerator and the denominator by the same square root. Since this is square root of 7, I'm going to want to multiply by square root of 7. The reason for that is that in the denominator, I will have the square root of 7 squared. And since it's a square root and a squared power, they would cancel and just leave us with 5 square root of 7 over 7. Now, what if instead of 5 square root of 7, it said 5 over the cubed root of 7? This changes the problem slightly. We're still going to need to multiply both the numerator and the denominator by the same root, but this time it's going to have to be a cubed root. And I'm going to need a group of 3. Since I have one 7 here, I'm going to need 2 more 7s. So I'm going to multiply by the cubed root of 7 squared in both the numerator and the denominator. When we do that multiplication, the numerator is going to end up being 5 times the cubed root of 7 squared, which was 49. And in my denominator, we'll have the cubed root of, because we got 1 7 here and 2 of them here, that would be 7 to the third power. The cubed root and the third power cancel, and that would be 5 times the cubed root of 49 all over 7. This is a very important distinction to make between square roots and cubed roots. With any sort of root in the denominator, we're going to want to get enough of them to cancel with the index of the radical. So if we're talking about the fourth root, I would need 4 radicands, 4 numbers underneath the radical, in order to cancel with that. In order to add or subtract roots, we can't just combine them into one root. We have to find common roots or like roots, which was first going to mean simplifying each of these. Now with the square root of 20, we know that 20 is 4 times 5, which is going to be 2 times the square root of 5. For my next term, I just have square root of 5, so I'll subtract square root of 5. And for the third term, this is 49 times 5. So square root of 49 is 7. And this will be square root 7 square root of 5. To finish it up now, think about each term. This first term says I have 2 square root of 5s. Then I'm going to take away 1 square root of 5, and with that result add 7 more square root of 5s. So 2 minus 1 is 1, plus 7 makes 8 square root of 5s. That's my final answer. Notice that I didn't do anything to the root. The root stayed square root of 5. Let's do that again in an example I. With this coefficient of 2 out in front, I'm just going to leave it for a little bit. And with 48, I want to find a perfect square factor. 16 times 3 makes 48. And the 5, 12 is 4 times 3. Simplifying each of those roots, we'll have 4 square root of 3 in the first term and 2 square root of 3 in the second term. Multiplying the two coefficients that are out in front, 2 times 4 is 8, and 5 times 2 is 10. Again, now we have like radicals because they're both square root of 3's. So now we just have to subtract them. 8 root 3's minus 10 root 3's, 8 minus 10 is negative 2. So we'll have negative 2 square root of 3 as our final answer.